All right, continuing with number 6 on this 2014 released exam. This says take the derivative of a big mess, right? So there's lots of chains here. If you want to think about this, this is sine of x squared all to the third power. And we're going to take the derivative of that. So we throw the exponent out front. The base stays the same. The exponent goes down by 1, so it becomes a sine squared instead of a sine to the third power. But we have to multiply by the chain, which is the sine of x squared here. So we're going to multiply by sine of x squared. So that would be cosine of x squared, but then we have yet another chain, right? When we took that derivative, we have to tack on, as I like to say, another 2x at the end. That's the derivative of that inside function. So I have 6x sine squared of x squared times cosine of x squared. So I scan over here. Do I see that answer? It looks like it is option E right there, option E. All right, moving along. Number 7, limit, a limit. Well, this problem, you can do it 2 different ways. Generally, I know that an exponential wins the game, wins the battle at infinity. So the bottom is going to be infinitely bigger than the top. So I kind of know that this is going to approach 0. But we could also use L'Hopital's rule. L'Hopital's rule says that we can do the derivative of the top and bottom. By the way, because this is infinity over infinity, we're allowed to do L'Hopital's rule. So the indeterminate form, 3x squared over 3e to the 3x, and then we could do it again, equals the limit as x goes to infinity of 6x over 9e to the 3x. I consider this to be kind of wasting time, but that's all right. I want to show you the full solution here. So then we take the derivative again, because it's still indeterminate form, and we get 27e to the 3x. Now we have a 6 over infinity. That's a constant on the top. So this definitely approaches 0, which is the answer on this. Again, I knew that the bottom was going to be infinitely bigger than the top because an exponential beats a cubic every single time. All right, moving on, number 8. All right, we're going to do U-substitution here. They actually tell us what the U-substitution would be. So I'm going to jump in here and write that down. I then take the derivative. Du would be cosine, actually 2 cosine of 2x, because you have to remember you have to tack on the derivative of that 2x, dx. So then if we plug it in, dx is going to be 1 over 2 cosine of 2x with a du on the top. So you see we're going to end up with a 2 on the bottom and a cosine on the bottom. So that's why we can rule out these options right here, because I know it's got to be an answer with a 1/2 out front. This cosine, when we plug it in, is going to cancel this one up here. So I've got the integral of u to the 5th with a 1/2 out front. I still have to change the bounds. I have to change the bounds. So I use their substitution. So I have to do u equals the sine of 2 times pi over 2. Well, that's just the sine of pi. And again, I would not be writing all this if I were taking the actual exam. I'd be kind of thinking it through. The sine of pi is 0. Okay, so the upper bound is 0. So the answer has to be D, because the other ones don't have an upper bound. But let's just check our work. Let's keep going. The sine of 2 times the lower bound was pi over 6. That's the sine of pi over 3, which indeed is radical 3 over 2. So option D is the answer. All right, number 9. A function has a derivative given here. They've given us the derivative. We don't have to find it. At what values does x have a relative maximum? So we're looking for something like this, where we change from increasing to decreasing. Okay, so what we do is we find the zeros first of all. We set this equal to 0. That happens at x equals 0, x equals 3, and x equals -1. I'm then going to do a sign chart. I like to do them different ways, but this is one way to do it. -1 up to 0, and then 3. Okay, and then we have infinity over here. So this represents 3 to infinity. This is -infinity to -1. So I have to do a sign chart where I decide whether it's increasing or decreasing. So if you plug negative bazillion into this, you get a negative times a positive, because when you square anything, you get a positive, times a negative. That's a positive, so we're increasing there. And then between -1 and 0, for example, maybe -1/2, -1/2 would be a negative times a positive times a positive this time. So negative, so decreasing. So right there we have a max because we're doing this, but let's keep going. Now pick a number between 0 and 3. How about 1? If you plug 1 in, you get a positive times a positive times a positive. That's a positive right there. Okay, and then if you plug infinity in, you're still increasing. So the only maximum is at -1. -1. All right, on this last one, this is an interesting question. It says we want this function to be continuous. All right, in order to be continuous, our limits have to be approaching left and right, and we have to be there also. Okay, so the limit as x approaches 2 on this thing right here has to equal where we really are at x equals 2, which is b. Now, if you factor this, this is x minus 2, x minus 5. Okay, we can then cancel these and rewrite the limit like this. X minus 5 over b has to equal b. You can then plug the 2 in there, and you get -3 over b has to equal b. If you multiply both sides by b, you get b squared is -3. That's never going to happen. You're never going to have a negative generated by a square. So there is no such value b. All right, we'll see you on the next video.